Today we're going to continue on looking at more identities, and the more practice we have and the more that you see completed and solved, the better you will get at them. Just keep remembering that patience is the key here. So our first example for today, just remembering we might have to factor, use common denominators, or multiply by the reciprocal. So our first example that we're going to try and solve is cos squared x. When it's divided by 1 plus sine x, does it always equal 1 minus sine x? So we start with our more complicated side. So I'm going to start to work with my left side first. And I remember that 1 minus sine squared x is the same as cos x. So we'll see whether that helps me or not. So I'm just going to label here that I know that because of the Pythagorean identity. We have to keep in mind that you have to state that on any test or assessment. 1 plus sine x, I'm going to leave as is for now because I don't have any rules that works with that. That sine is not squared. I realize at the top here I have a difference of squares, and you will, after much practice, get better at recognizing that. So I can square root the first term. Square root of 1 is 1. And I can square root sine squared. It's just sine. Then remember, with the difference of squares, means you write it again with the alternate sign. You can already probably see that the denominator is going to cancel out as a result of finding that factoring. That is the same as that, so they cancel out, and then my left side equals my right side. We'll just get it down so that they are the same. Therefore, left side equals right side, and you're done that proof. Our next example today, example B, is does 1 plus cosecant always equal sine x plus 1 over sine x? In this question here, I'm going to do common denominators on my right side. You know what? I'm not even going to do common denominators yet. I'm just going to split these apart. So I have sine x over sine x plus 1 over sine x. So that denominator is with both parts of the numerator. So what I have here, sine over sine equals 1 plus 1 sine x. And from our reciprocal lesson with identities, I know that 1 over sine x is the same thing as cosecant. So I've just proven that left side equals right side. It's just a matter of remembering our tricks. All right, let's look at our last example for today, our example C. Let's see if cotangent theta is always equal 1 plus cotan all over 1 plus tan. So just on my left side, I'm just going to remind myself here that, excuse me, I've written that upside down, that cotangent is when cos theta and sine theta are on top of each other. And then I'm going to do the same over here. So for cos tan, that's the same as cos theta over sine theta. And we know this because of our quotient identity. So I didn't do that in example B, but remember to always label your identities that you use along the way. This is all over 1 plus sine theta because of our quotient identity as well, cos theta. I'm going to make some common denominators here. Sine theta over sine theta plus cos theta over sine theta. So I just made this denominator sine over sine. And then I'm going to do the same thing in the denominator of cos theta over cos theta equals 1. And now I have common denominators to do some adding. So on the top I have sine theta plus cos theta all over sine theta. And then our large fraction, that's the theta there. Make some space. And then in the denominator, I have cos theta plus sine theta all over cos theta. So again, when I have fractions on fractions, if I take the reciprocal of the second term, I can make it multiplication. So here I have sine theta plus cos theta all over sine, multiplied by cos theta and cos theta plus sine theta. You can see here that my numerator and denominator down below are the same, so they will cancel out. And that leaves me with cos theta over sine theta. Cos theta, my final answer, all over sine theta, which is great. You can see if you move all the way back up to where we started, your left side and your right side are now equal to each other. Therefore, left side equals right side, and you're done. And we didn't use any other identities along the way, so I don't have to go back and label anything but the quotient identity. And that question is done, and we will have more practice questions from page 310 to do tomorrow in class.